Then we continue with what? Part 2 of this scientific unit. We continue what with this. We stop at charge. Now let's talk about the young modulus. Young modulus. Now young modulus is equal to stress over strain. Now they want to talk about what? Stress. Stress is what? Force over what? Area. Force over area. Then what about what? Pressure. Pressure is also depicted as what? Force over what? Area. That means that all of these have a unit called what? Because strain, sorry, this strain. Strain does not have a unit. Please take note of that. Strain is unitless. So since strain is unitless, stress is what? Force. And force is Newton over area, which is per meter square, which is what? Newton per meter square. The same thing for what? For what we call it stress. The same thing for pressure. Let's take on that. Then we have what they call frequency. Frequency is what? Is what? 1 over period. Frequency is 1 over period, which is what? Measured after a man called Haynes. Capital letter H and Z. Because we use capital letter H because of what? Is named after someone. And it's also what? Per second. Don't forget, period is fundamental. If they ask what is fundamental, is period a fundamental or derived quantity? The answer is period is a what? A fundamental quantity. It's a family of time. It's a family of time. We have what also called velocity gradient. Velocity grad. Velocity grad is the same thing with what? Has the same unit as per second. It means what? Velocity divided by time. Please, divided by length. Anytime we mention velocity gradient in physics, is we are talking about what? Something divided by what? By length. Please take note of that. Temperature gradient means change in temperature divided by length. I have not mentioned rates for you. I'm mentioning gradient now, which is what? This one now will not be also measured. Don't forget, this one measured meter per second divided by meter. Meter will cancel meter, we have per second. That's why it's measured. We have what they call decay constant. Decay constant is a unit, is at the formula of 0.693 over period, which is what we call length over period. That is the formula for decay constant. And that unit is also what? Per second. Now, what we are laying, the foundation we are laying here is to be able to know enough formula. There's what we call what? Angular velocity. Angular velocity is having the same unit as all this, which is what? Angular velocity is what? Angular displacement. Angular displacement over what? Time. Angular displacement over time. Angular displacement over time. That's what we call is angular displacement over time. So I shorten it so that I put dot here. So now don't forget it was also measured in what? Rad per second. Rad per second. Why is it rad per second? Angular displacement is measured in rad. Time is measured in seconds. So rad over second is what? You know, we have what they call angular what? Acceleration. Angular acceleration is what? Angular what? Velocity divided by what? By time. We can write it as omega divided by t. Don't forget, angular velocity is what? Written as omega. Decay constant, the symbol is this. Velocity gradient is what? You can write it as v grad. Frequency is what? This. The pressure is p, as the case may be. Now, what we call angular velocity as angular acceleration has what? Rad what? Per second square. You see from that. And the unit is still what? Rad expressed in fundamental is rad per second square. We have what they call angular velocity. I think angular what? Momentum. Now, don't forget, there is one thing I need to show you here. We have the family of linear. We have the family of what? Angular. What is displacement in angular? Linear is displacement is x or x, but in angular this is linear, linear, and we have what? Angular. So in linear, the displacement is x or x, but in angular we write it as what? As theta. What about what? Velocity is written as v, but in angular we write it as what? Omega w. What about what? Acceleration. Acceleration in linear we write it as a. Please don't forget. But in angular we write it as alpha. Please take on that. We also have what they call, we are talking about angular velocity. We have what they call mass. Mass in linear is m, while mass in angular is called moment of inertia. Moment of inertia is equal to product of mass times radius of gyration square. That means the distance square. That k is what we call radius of gyration. Now, what is force in linear? Force is F. What about force in angular? It is called tau, which is called torque. Torque is what the force in angular motion, and so forth and so on. So if you can know this, it will help you to what? To differentiate between angular and what? And linear. So these are the basic ones. Somebody asked me, oh, Mr. Lide, do we have the angular time and linear time? Sorry, my dear, we don't have anything like angular time or linear time. What we only have is for what? Displacement or distance, and the angular is what? Theta. What we have linear velocity, and the angular is w, which is angular velocity. We have linear acceleration, which angular is what? Angular acceleration. We have linear mass, which is m, and the angular is what? So if I want to ask a question from the people that are watching this video now, if force is equal to ma, what will be what? The angular torque or angular force? It will be what? I alpha. So now let me stress something further. If we have work done, work is equal to what? Force times distance. Who cannot tell me now? You now notice that what? The angular, in terms of angular, work is equal to what? Class tau times what? Distance. Distance is theta. Don't forget. Force times distance is equal to theta. So now when we talk about angular momentum, angular what? Momentum. It means we are talking about angular motion. Where linear momentum is mass times velocity. So angular will not be what? I, which is equivalent to mass, times what is the velocity for what? Now be omega what? As it is. Now that means angular moment of inertia times what? Angular what? Velocity. Now what is the unit? The unit will not be what? Kg, which is the mass, meter square, which is the what? K square, which is distance square. Then what is formula for the unit of angular velocity? We have done it before. It's here. So we are going to have what? Rad what? Per second. Rad per second. We have what they call what? We have talked about angular one. Then we have what they call what? Gravitational constant. Gravitational constant. I believe it's a formula you should know. From what? Universal law of gravitation. F equal to gm1 m2 over what? R square. My dear, if you make G the subject of formula, what you have? G becomes what? Fr square over what? Mn mass 1 mass 2. And what is the unit? It becomes Newton meter square divided by kg square. Because kilogram multiplied by kilogram will give us kilogram square. So somebody can write that as what? Newton meter square per kilogram. What if somebody want to break it down? Remember that Newton is equal to kilogram meter per second square. So if I now put it and multiply this one, you discover that kg meter per second square multiplied by what? Meter square multiplied by kg per second per kg. Now per kg and kg, if you do the indices, what I want to have is what? Per kg. Because kg raised by 1 multiplied by kg raised by minus 2 will give us kg raised by minus 1. Meter times meter will give us what? Meter cube. Meter cube. And thereby, second square is now left, so we put it what? Per second square rather, that will now be left. So what I'm trying to say, if Newton is all this, you can replace it here and what? Break down this formula in terms of what? Fundamental quantity. We have what they call what? Compressibility. Compressibility is equal to what? Is equal to what? 1 over Young modulus or bulk modulus. So 1 over bulk what? Modulus is equal to what? Compressibility. Recall that what? Anything modulus is measured in what? Newton per meter square. So what do you have? 1 over Newton per meter square becomes what? Per Newton per what? Per Newton meter square. And that can give us what? 1 over kg meter per second square. Remember that anything that is written as 1 over n is saved as n raised to power minus 1. Recall. So that is what? 1 over n now is the same thing as n raised to power minus 1, which is what? This times what? Meter square. If meter cancel meter square remain meter, what do you have? If and let kg go up, class. Take the kg up. What do we have? We have per kg. Let's say super minus 2 go up. Become what? S square then per meter. That is the unit of what? Compressibility. So what we are going to have is what? This one go up. Then this one what? Okay, this is just ordinary one. Just this power 1 because it's already up there. So no need to put what. So that is the unit of what? Compressibility. There's what we call coefficient of viscosity. Coefficient of viscosity. Don't forget, there are coefficient of viscosity and coefficient of friction. Coefficient of friction does not have a unit, which is what? Coefficient of friction is mu, which is frictional force of a normal reaction. But this one is what? Is defined as tangential stress over what? The velocity gradient. So if you what? Say that coefficient of viscosity is defined as tangential stress over velocity gradient. That means that the stress is what? Newton per meter square. What about gradient? And don't forget, if what? That is your what? Your now, I don't understand that one. Now, let's see what we are going to do there to break that unit down. So this one now becomes what? It becomes what? Tangential stress, then the coefficient of viscosity symbol most of the time is what? This is equals to what? Newton per meter square, which is what? Kg meter per second square, which is Newton times what? Per meter divide by what? What is velocity gradient? I've told you before, is per second. Don't forget, I gave you, check the video that done for velocity gradient, which is the same as frequency. What do we do now? Let's break it down. It becomes what? Kg, which is standing, you know, meter times meter raised to power minus 2 will give us meter times raised to power minus 1 or meter raised to power minus 1. Then seconds per second divided by per second square divided by per second will give us what? Per second. Because if these two, s raised to power minus 2 divide s raised to power minus 1, we have s raised to power minus 1. That is the unit of what? Of what? Coefficient of viscosity. We have what they call what? Inductance of an inductor. Inductance of an inductor. Inductance of an inductor is measured in, it is measured in what? You can write it as energy times 2 divide by what? Current square. What does that mean? Don't forget, energy equal to what? Is equal to half what? Li square. So if you make L the subject of the formula, the symbol for this is what? L. So L is what? If you make L the subject of the formula, multiply the energy by 2 and divide by current square. So that is to say, that is the unit, the formula. So the unit will now give us what? What is the unit? Joules per what? Ampere square. Or what we call what? What? Henry. Capital letter K, name after someone. Henry. You can name it. We can also write it as what? Kilogram what? Meter square per second square per ampere square. How? Joules is what? It's the same thing with what? Kilogram what? Meter square per second square. That is joules. Then divide by ampere square. Don't forget, how does that one come in? Current what? Square. Current square is what brought about ampere square per ampere. Now we have what they call capacitance of what? The capacitor. What is capacitance of the capacitor? It is what? It is equal to what? CV equal to V. It's equal to Q. So that is, so the capacitance of the capacitor is equal to charge divided by what? Potential difference. So C equal to charge what? Divided by what? Potential difference. So what is charge now? Charge is measured in coulomb. While what? Potential difference is measured in what? In volts. So that means we can also say it's a farad. Farad, capital letter F, after someone. We name it after someone. We have several of them. We have gravitational field. Gravitational field is the same thing as what? As force divided by mass. So force divided by mass, which is equal to what? Newton per what? Per kilogram. We have what they call what? What they call electric field. Electric field is what? Force over charge. Force over charge, as well, which is measured in Newton per coulomb. And we have what they call what? Gravitational what? We have what they call what? Magnetic field. Magnetic field is equal to what? Force divided by velocity times what? Charge. So if you now want to break it down, it is measured in Tesla, name after somebody, capital letter T, or measured in Newton per Weber. Let me just use Tesla. Let's use Tesla. So that is, we have several of them. We have what they call impedance. I think I did not give you surface tension. Surface tension. Surface tension is what I will give you last, then we'll end the video. Surface tension, then I'll give you some assignments to go and do and submit at the comment section. Because we have a lot of them. If I continue like that, we will just continue and continue. Now, what I will give you now is what? Surface tension. Surface tension. Okay, I've talked about impedance. Impedance is also the same thing as velocity, potential difference divided by current. Impedance is the same thing as resistance. Resistance is also V over I. Surface tension is force over length. It's the same thing as Newton per meter. We have what they call what? Force constant. Force constant also the same thing as what? Force over what? Extension. We have that one. We have pressure, which is Newton per meter. We have pressure. No, we have talked about pressure. Density. Density is mass over volume, which is what? Kg per meter square, per meter cube. And so forth. We have what they call electric potential. We have talked about it. Magnetic field. I have to give you magnetic field. and so many of them that we can talk about. There are so many. There are so many. So I believe that at least we'll be able to what? To understand majority. There are several of them. This one is measured in what? In ohms. Name after a man. We can write it as what? We can write it as volts per ampere. In other words, if you want to write it in terms of fundamental quantity, you can write it as kilogram meter square per second cube divided by what? By ampere square. It can be written like that. It can be written like that. So you can, they ask you what is the fundamental unit of what? Of ohms. It can be written as kilogram meter square per second cube per ampere square. So the same thing with this one too. The same thing with this. This is ohms, or this. The same thing with this one. So this one is what? Kilogram meter per second square divided by meter. So our unit is what? Kilogram per second square. So the same thing with this one, kilogram per second square. So I think I cannot exhaust this video, but I've tried my best to what? To try to what? Touch all the necessary areas we will need. We have several of them. We still have several of them. But these are the basic ones that you need for now. So I believe I'll be able to what? Explain everything you need for now. God bless you. Ensure you subscribe to always get more. Thank you.